So with this one, it's still, we're talking about unit fractions. We're still working with the same thing, but now we're getting a little bit more technical with it. The main focus now is not having improper fractions. So then we got to reproperize them, but we know how to do that. So with 13(2), Doris lives 1/4 of a mile from school. If she walks to and from school each day, how far does she walk during a school week? 1/4 there, 1/4 back. So 2/4 a day, right? Yeah. Monday, Tuesday, Wednesday, Thursday, Friday, that's 5 days. So she walks 1/4 of a mile 10 times a week, right? Yeah. Now I could show 1/4 as this. 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. No. No. That's too much. That's silly. What I'm going to do is I multiply it. 1/4 10 times. Now, in this case, always, I am not making an equivalent fraction. I am multiplying the fraction, meaning the denominator does not change. That stays put. It will always be over 1/4. And then, hello, doing multiplication with 1. 1 times 10 is 10. I'm not done though, because now I need to make it proper. First off, can I make it more simple? Can I simplify it?
Yes.
Yeah. 10 can become 4 can become 2. Okay. Now, how many times can 2 go into 5?
Twice.
2 times, because 2 times 2 is 4. 5 minus 4 is 1. And I keep my denominator, half. So she walks 2.5 miles a week. That's not a lot. 2.5 miles a week. Now, another way I could have done this, which would have gotten me the same result, was by going, okay, well, 2/4 a day for 5 days. 2/4 times 5 equals 10/4. It's still the same thing. It's just I'm using the actual per day instead of unit fraction. If you want to do it that way, you can. You'll see some problems that are like that anyway. Basically, what I'm doing when I'm multiplying is the problem looks like this. I turn it into 5 times 2/4 pretty much equals 5 times 2 times 1/4. I'm making it all fancy and spending a lot of time on it. I don't need to do all of that. I understand what I'm doing, but this is breaking down what I'm seeing. Okay? So let's look at this picture here with the pies. I have 2 pies here, and I have 1, 2, 3, 4, 5, 6 spaces in it, but 2 of those spaces actually have pies in it. So 2 out of the 6 spaces have pie. 2/6. And there's a second one that's just like that. So there's 2 of them. So if I were to write a multiplication sentence, 2/6 times 2 equals 6 stays put. 2 times 2 is 4/6. Can I simplify that? Yes, I can.
2/3.
2/3. And that's it. That's the answer. Now, I'm looking at a number line on number 2. This number line is, I can tell, it's broken up into thirds because that's the denominator is at 3. And it goes all the way up to 2 2/3. And I need to come up with a multiplication sentence for that. Okay, well, I'm going to work backwards. My answer is 2 2/3. My answer is 2 2/3. How did I get there, though? Well, my unit fraction is 1/3, and that's how a fraction works. It just goes up by thirds. So if I have 1/3, and then I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. I went up 8 times. 1/3 times 8. Now, 8 times 1, that gets 8/3, right? But if I were to properize, 8/3 would become 2 2/3. Let me prove it. 3 goes into 8 2 times, because 3 times 2 is 6. 8 minus 6 is 2/3. Ta-dam! Okay, so this is pretty straightforward. Let's look at number 4, because number 4 is just meant to mess with your brain for just a bunch of giggles. They're just purposely trying to mess with you, and don't let them do it. So look at number 4. It says, draw a picture to explain why 3 times 2/5 equals 3 times 2 over 5 equals 6/5. Now, when you look at that, your brain probably goes into a small little panic. You probably start thinking of, this is like in those movies when the crazy super smart math person at the board in college is writing all these random equations on a board that have parentheses and fractions. That's what it looks like. Don't be freaked out by it though. It's really not that bad. What this here is showing is what you're doing in your head. Let me rewrite it again and show you the way that we have been solving it, and you'll see why it looks like this. So 3 times 2/5 equals, well, the 5 stays put, so that's over 5. And all I do now is 3 times 2, which is 6. So this is just showing what your brain should be doing. But they put it on paper because it looks like crazy super math stuff, and your brain shorts itself out. It freaks out. So that's when you go, not today, math. I see your scheme and I will beat you at this game. This is just what your brain is doing. 3 times 2, 3 times 2. That's it. Now it's asking for a picture. Okay, well, I'm going to think of like the pies. I'm not going to try and draw a circle and divide it into 5, but hey, guess what? I have grid paper. 1, 2, 3, 4, 5. Do another one of those. Oh, do another one of those. Why did I make 3? Because it asked for 3. And how much of it will I be shading in? 2 out of each one. This picture now shows 2/5 3 times. Get it? Okay, cool. Let's look at 6 and 7 and then we're done. 6, what's my unit fraction? 1/8. How many times do I see 1/8? 5 times. So I am writing 5 times 1/8 equals 5/8. Can I simplify? No, I cannot. So I'm done. What do I see here? I see 2 pieces of pie on 3 plates, and I see a fraction underneath it, 2/10. Okay? So I see 2/10 3 times. So I am doing 3 times 2/10, which is 6/10. Can that be simplified? Yes, to 3/5. Okay? So it's really not that bad, right? Once you get the hang of it, like everything in math, it goes from being challenging to fun.